Okay, microeconomics students, we're going to be looking at the cost of the firm and perfect competition. So the first thing, the cost of the firm. Businesses incur certain costs. A fixed cost is a cost that stays constant no matter how much you produce. It could be the cost of your factory rent, your store's rent, a business license. Those are costs that stay the same no matter how much you produce. So we know as fixed cost stays the same. Variable cost is the cost to make the product. As you produce more, your variable cost goes up. Now, your fixed cost plus your variable cost equals your total cost. So these three things have to add up together, and they do on my chart here. Marginal cost. Marginal just means each additional. So when we start at 0, it's just NA. From here to here, it went up by 8. From here to here, it went up by 4. From here to here, it went up by 3. From here to here, it went up by 3. We could have also looked at the difference in the variable cost to figure that out as well, since our fixed cost stays the same. Now, my last three columns that are in green, this is average fixed cost, average variable cost, and average total cost. Well, how do you find the average of anything? You divide by the quantity. So average fixed cost would have been fixed cost divided by quantity. So 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 3 is $6.67. 20 divided by 4 is $5. Average variable cost is just your variable cost divided by quantity. And your average total cost is just total cost divided by quantity. Now, the other tool that you have on some of these cost of the firm questions is these three things will add up together as well. So that's another way for you to double check your work. Now, it's very common when you look at the cost of the firm for your cost curves to look like this. If we were to plot these out with a price on the y-axis or cost on the y-axis and quantity on the x, it's very common over time for marginal cost to initially go down and then up. It's very common for average total cost and average variable cost to form a parabola. Now let me point out a couple other things mathematically. The low point of AVC, the low point of ATC is where it crosses with MC. Now the other thing is that these are going to get closer and closer together. Remember, if average fixed cost plus average variable cost equals average total cost, then the difference between these two lines is your average fixed cost, right? The difference between this and this must be your average fixed cost. Well, let me go back to this over here. Your average fixed cost is getting lower. 20, 10, $6.67, and 5. So since that's getting lower, because you keep dividing by a higher number, then as you go on with this, these two lines have to get closer and closer together as well, because average fixed cost becomes lower and lower. Okay, so here's what those cost curves typically look like. Of course, ATC is above AVC. These two kind of look like parabolas. This looks like a check mark looking thing or a Nike swoosh looking thing. Now, perfect competition. Let me remind you what perfect competition is. Thousands of firms selling identical goods, low barriers to entry, meaning there's not a lot that would prevent another entrepreneur from copying and entering the market. There's also no profit, no loss in the long run. So here we have MC, here we have ATC. I didn't put in AVC because it just gets to be too big of a mess, but we could put that in as well. It would be a parabola looking thing underneath ATC. So here's the market. This is all the businesses together. Supply and demand determines a price of $5 and a quantity of 1 million. They're a price taker. They just accept the going price decided by supply and demand. This is perfectly elastic demand. What does that mean? This means that consumers are hypersensitive to even a 1 penny price change. So they're just accepting the going price of $5. So that means $5.01 and there's no demand for it. This becomes those four things. So if you're charging $5 for every single one, then the additional money you bring in is $5, right? If you sell one or if you sell two or if you sell three, the additional money, which would be called your marginal revenue, that comes in would be the same, $5. Or if it was $3, then it would be $3, okay? But marginal revenue is the same thing as your price. Also, your average revenue. If you're charging the same price for every single one, that's got to be the average amount of money that you bring in. If it's $5 that you're bringing in, that the price is, then the average amount of revenue that you bring in is $5. Okay, and again, we also said that this is a perfectly elastic demand curve. This is the consumer's demand for our product. So I call this Mr. Pard, just a straight line. Then I brought in MC. Now, the ultimate rule in economics, mathematically, what's going to maximize profit is that you produce up to where MR equals MC. That is your profit maximizing point. That's what's going to maximize profits mathematically. So here's MR, here's MC, and I put a dot there. I trace down, there's the quantity that's going to maximize profit. That's based off of MR equals MC. Again, maybe the most important rule in economics. Now, we also want to find in this graph the profit. Profit is total revenue minus total cost. On this graph, I have the average revenue and I have the average total cost. So I want to find the difference between those two things from Q star. So I trace straight up until I hit, well, I'm going to hit ATC first. And then trace over this way. Then I have AR above it. So this box here is the gap between the cost and the revenue. And cost was lower than revenue. So that area there that's red is our area of profit. Now, what are the other entrepreneurs outside the market going to do? Well, they see that there's profits to be had. So more people want to be part of this market. So you're going to see more entrepreneurs flock to this industry. And they'll be able to because there's low barriers to entry. So supply is going to go up as other firms join. Other firms join the market, supply goes up. And with more competitors, that brings prices down. That should make intuitive sense. And with more competitors and more businesses producing, we're going to see more being produced. I'll say now it's 1.1 million. Now if I trace over this way, and if I were to show Mr. Pard 2, that profit box would then be eliminated because prices came down, and then we would have like Mr. Pard 2, I suppose, here. So they're not making a profit in the long run because when profits are to be had, more firms join and that drives prices down. Okay? So that's why we said this part. There's no profit or loss. Let me show you the next one. Here's the same setup, except this time I put ATC way up here. Again, found the MR equals MC point. Again, that's the most important rule in economics. There's the point where MR equals MC. There's our quantity, Q star. This time I put ATC way up here. So now if I'm asked for a profit, the difference between total revenue and total cost, again, I have the average of both of those. So I trace up and then I trace over. This time it forms this box. This time average total cost is way up here. Costs were higher than revenue, so this is our area of loss. So what are the businesses going to do in the long run? They're going to exit the market. They're not just going to keep losing money year after year. They're going to go out of business, and that looks like a decrease in supply as businesses are exiting in the long run. Remember, that's a long run decision to exit the market. Now with less competitors, maybe the price goes up to 6. And maybe now our quantity here is 900,000. I'm just making up those quantities, but I see that it would decrease and I see that the price would increase as firms leave the market, as there's less competition. So in the long run, if there was profits, firms joined and those profits were eliminated. If there was a loss, firms exited the market. So in the long run, we're eventually going to have no profit, no loss. We're going to have a graph like this, where they call this long-run equilibrium or long-run competitive equilibrium, or just no profit, no loss. Here, when I trace up from Q star, again, it's the same exact setup, right? But if I've tried to find the difference between the revenue and cost this time, I don't find a difference. There is no difference because ATC is going right through there. So this is no profit, no loss. One reminder here. Is this firm here where we're saying no profit, no loss, are they really making $0.00? Actually, no, because economists always consider the opportunity cost. So this no profit, no loss considers opportunity cost, meaning they're just not making, anything greater than the next best thing that they could spend their time doing. This entrepreneur might be making some money, but that money is no greater than the next best thing that they could have spent their time on. Now, let's turn to reading the graph. Here's a type of question that the College Board likes to ask, and this is no more difficult than something we'd look at in geometry or an algebra class. Okay, quick reminder before we start. To turn an average into a total, you want to multiply by the quantity. So here it is again. Now, by the way, on my other graphs, again, I didn't have AVC always drawn in there, but if it was drawn in, it would just be a parabola-looking thing below ATC. Now, average variable cost is just the cost to make the product. So I just want to remind you of that as well. First, what is the profit maximizing quantity here? So I've got all these quantities down here, but I keep saying we're producing up to where MR equals MC. So here's MR, here's MC, here's where they cross. Our quantity, our profit maximizing quantity is 100 units. What price is being charged? Well, our Mr. Pard line, remember this is marginal revenue, price, average revenue, and demand. So the price that's being charged is $7. What's the average revenue? Well, it's also going to be just the $7 because the AR stands for average revenue. What's the total revenue? Again, this is back to our reminder. To turn the average into a total, you want to multiply by the quantity. So if our average revenue is $7 and the quantity that we're sticking with is 100, that's our profit maximizing quantity. So $7 times the 100 gives us $700 of total revenue. What's the average variable cost from the profit maximizing quantity? Go to 100 because that's our MRMC quantity. Trace up to average variable cost and trace over. So trace straight up till you hit average variable cost, trace over, we see it's $4. So average variable cost, $4. What's the total variable cost? Well, if the average was 4 times the quantity of 100, that's going to give us $400 of total variable cost. A few other questions. What is the average total cost from the profit maximizing quantity? Average total cost. So trace up from 100 till you hit average total cost, and it's $5. What's the total cost? Well, if the average is 5 times the quantity of 100, this must be 500. The profit. Profit is total revenue minus total cost. So back here, our total revenue is 700. Our total cost was 500. So profit, again, is total revenue minus total cost. That's 200. What will happen in the long run in this market? Well, they're making a positive profit, right? There was a profit. ATC was below the Mr. Pard line. There's lower cost than revenue. So if there's a profit, other firms are going to join the market and the supply curve will shift up. So what will happen in this market in the long run? Other firms will join. One more side note. Going back to the loss. Again, I don't have average variable cost drawn in on some of these graphs. But let's say the average variable cost was way up here. Okay, I know that's not perfect and those are supposed to get closer together, but let's say the average variable cost was way up here above the Mr. Pard line. This would imply that it's costing more to make the product than the price that they could sell it for, because that's what average variable cost is, the cost to make the product. If that's higher than your price, then you immediately want to shut down. Shutting down means does not mean go out of business. You'll do that in the long run. Shutting down means today in the short run, stop production. So here's the shutdown rule. If average variable cost is greater than or equal to the price that you can sell it for. So if it costs more to make the product than the price that you can sell it for, right now in the short run, you will shut down. Now, in the long run, yes, you're going to go out of business and cease to exist as a company. But shutting down means right now, we are going to decide to not produce this Q star, but we're going to actually decide to produce zero, produce nothing.